Now let us derive the equation of the standard hyperbola. Okay, for this we consider the frame of x and y axis. Right, now let's consider an arbitrary location of the directrix whose equation is, say, x equal to k. So clearly the point where it meets the x-axis is k comma 0. Let's call that as point, say, M. Alright. Now let's consider the focus, which is S, and let its coordinates be h comma 0. Now one possible location of one point that lies on the hyperbola will be, of course, on the line joining M and S. So that is on x-axis. You can imagine that there might be somewhere here a point, say P, with coordinates, say a comma 0, which is lying on the hyperbola. Now if you remember, for hyperbola the eccentricity is greater than 1. That means the distance of any point on the hyperbola from the focus is more than its distance from the directrix. So in other words, we can say that every point on the hyperbola is closer to directrix as compared to the focus. So therefore, we have shown here P to be slightly closer to M as compared to point S. Okay. Now with that, let us visualize that this P divides SM in the ratio E:1 internally, correct? Because P lies between M and S. So with that we can write the coordinates of P using the section formula for internal division as A is equal to 1 into H, that is H, plus E into K upon 1 plus E. Okay. So clearly on cross multiplying we'll get A plus AE is equal to H plus EK. Okay. Let's call this as equation 1. Now we can also imagine another point lying on the other side, say P dash, which is symmetrically opposite, so which will have coordinates minus a comma 0, because we can think of this point also to lie on the hyperbola, considering that it divides SM but now externally, right, in the ratio E:1. Okay, so therefore writing its coordinates and writing the formula of section formula for external division, we have minus A is equal to H minus EK upon 1 minus E. So therefore on cross multiplying we'll get minus A plus AE is equal to H minus EK. So let's call this as equation 2. Now if we add the two equations, that is 1 plus 2, okay, that gives us 2AE is equal to 2H. So therefore we get H is equal to AE, which is an important find. And if we subtract, that is, if we do 1 minus 2, then we get 2A is equal to 2EK. So therefore from this we get K to be nothing but A upon E. Okay, so we got the expressions or the values of H and K in terms of the known quantities A and E. Right. Now it will be interesting to note that there will be countless such points where the ratio of their distances from focus to directrix is equal to E, which is numerically greater than 1. Okay, so if we join all such points, we will get a curve like this, and there will be another branch also. So this together makes one hyperbola. Right? So if you see, these are not two different curves but the parts of the same hyperbola, and like the previous directrix, you will have symmetrically located another directrix on the left side whose equation will be x equal to minus k. Okay, and here we know that now we have derived that k is nothing but A by E. So therefore those are the equations of directrices. Okay, now with these two important terms, now we go ahead to further derive the equation. Right, now in this case we consider any general point now, that is, this is the directrix and its equation we write as now in standard form, that is x minus a by equal to 0. Then this is the focus S, which we now know h is nothing but AE, so the focus is AE. Now let's consider some generic point P lying on the hyperbola. So its distances from the focus and the directrix are shown here. Let the coordinates of the general point be x comma y, and that point is lying on the hyperbola. So we are deriving a generic condition for that hyperbola. Right. Now by the focus directrix property we know that the ratio of SP is to PM is nothing but the eccentricity. So therefore we can say that SP is E into PM. Right. Now SP can be written with the help of distance formula, isn't it? So it's the distance SP, so that turns out to be x minus AE the whole square plus y minus 0 the whole square and everything inside the root. That is equal to E times. Now the distance PM can be written with the help of the formula for distance of a point from a line. So we write that formula, we have the x term, there is no y term. So we write A upon E divided by root of x coefficient square, which is 1 square, and y coefficient square is 0 square. So therefore on simplifying we get x minus AE the whole square plus y square is equal to, now taking E inside the modulus because E is a positive quantity, we will have EX minus A on the right side. So clearly to get rid of the square root as well as the absolute value on the right side, we have to square both the sides. So on squaring and opening the square of x minus AE, we get x square minus 2AEX plus A square E square plus y square is equal to E square x square minus 2AEX plus A square. So we see the term minus 2AEX gets cancelled from both sides. Let's collect all the x and y terms on left side and transfer all the constants on the right side. So therefore we have 1 minus E square common with x square plus y square term as it is, and on the right side we have A square into 1 minus E square after clubbing the terms. So let's divide throughout by A square into 1 minus E square like we did for ellipse. So therefore we get x square upon A square plus y square upon A square into 1 minus E square equal to 1. Now comes the important point. If you remember, in case of the derivation of the equation of the standard ellipse, we had replaced this denominator as b square. Okay? But now here we can't do that, simply because if you observe b square, since it's a square of some real number, it has to be non-negative. Right? But if you look at the term 1 minus E square, since for hyperbola E is greater than 1, therefore we have E square greater than 1. So therefore 1 minus E square turns out to be less than 0. That means 1 minus E square is a negative quantity. And A square is definitely a non-negative quantity. In fact, it will be positive number because A can't be 0. So therefore, as a whole, this denominator is turning out to be a negative number. So if you want to replace it with b square, that is the square of some number, then we have to first make it positive. And that can be easily done by simply changing the sign of 1 minus E square to E square minus 1. So therefore we can change the outer plus to minus. Okay, so therefore let's do that. So we'll get x square upon A square minus y square upon A square into, now we flip the terms inside, E square minus 1 equal to 1. And now we can replace or substitute A square into E square minus 1 with some number b square, and hence finally we will get the equation as x square upon A square minus y square upon b square is equal to 1. Right, so that's the final equation of the hyperbola, and we know in this b square represents A square into e square minus 1. Right, so that's the equation of the standard hyperbola as shown.